everyone, and welcome to a new episode on AI Fridays. Alright, so today we're going to talk about how can we build a simple artificial neuron. Okay, so this is kind of the building block of how can we build an artificial neural networks. Okay, so a lot of applications are actually happening right now when it comes to artificial intelligence in general, or artificial neural networks. You can see that in self-driving cars. You can see them in speech recognition, like Siri, for example. And you can see it in tons of applications everywhere. Face recognition and so on. Okay, so let's see how can we build that. So as you guys can see here, so what happened is, in order for us to build a simple artificial neuron, what we're going to do, we're going to take a look at how our human brain works. And what scientists did, which is really fascinating, is that they tried to imitate that. They looked at it and said, you know what, let's take a look at how our brain works and let's imitate that mathematically. So just bring in a bunch of equations that represents or imitates how our biological neurons work, and here we go. Now we can actually build, kind of think of it as a mini brain. You can teach it whatever you want. You can teach it to classify traffic signs. You can use it to drive. You can help it, to classify, let's say, like faces. It's really fascinating. So as you guys can see here, first, how many neurons does our brain have? So our brain have over hundreds of billions of neurons. Think of it as just, all these neurons are communicating to each other, sending electrical and chemical signals and just firing, like talking to each other. And in the same fashion, what we're going to do, we're not going to build, hundreds of billions of neurons, but let's say we're going to get, 100 artificial neurons, connect them together, and then build an artificial intelligence in a way. So before we go into the artificial one, let's take a look at how can a biological neuron works. All right. So as you guys can see here, this is simply a model of our brain, or just one single neuron. As you guys can see, we have a bunch of dendrites. Okay, think of it as kind of like branches that's taking signals from the outside world. Okay, so these are the different branches, which we'll call it dendrites. And what happened is, these branches, all these signals are sent to a nucleus, as you guys can see here, which is some processing takes place inside, and then it generates an output, and this output is being sent to what we call it the axon. Okay, and that output is being connected to another neurons, and then these neurons are connected to another neurons, and you keep doing this, in hundreds of billions of them, which is incredible. Okay, all right. So that's how our biological neuron works. So we're not interested actually in our biological neuron. What we want to do, we want to build an artificial neuron. We want to build an artificial neuron that imitates how our biological neuron works. So let's see how can we do that. So, so you guys can see it, excuse me. Let's assume that we have only 3 inputs. And these inputs, we're going to call them X1, X2, and X3. And as you guys can see here I have 3 weights. Okay, and we're going to learn, or you're just going to hear me talking about weights a lot in future episodes, and this episode too. Think of weights as kind of, like a way of assigning importance to some inputs compared to the other. For example, these weights are weight 1, weight 2, weight 3. Weight 1 of value 0.7, weight 2 of value 0.1, and weight 3 of value 0.3, which means that weight 1 have like a higher importance in a way compared to these other 2 weights. Okay, I'm going to discuss that in a lot more details moving forward. So let's take a look at how how can we build an artificial neuron. As you guys can see here I have a bunch of inputs, and these inputs are of value 1, 3, and 4. And what happened is, simply put, you're going to multiply the first input, which is X1, by the first weight, which is weight 1. As you guys can see here I have X1 times weight 1 plus the second input, which is X2, multiplied by weight 2, by W2. So X2 plus W2, and then X3 times W3, as you guys can see here, plus the values of what we call the bias signal, which is that B bias here. Think of a bias as kind of a way of shifting the function up and down, okay? Don't worry about it. Let's assume that bias here is just 0, okay? So this is simply our equation. And this is simply the output coming up here. We're going to sum them up. So we're going to sum up x1 times weight 1 plus x2 times weight 2 plus x3 times weight 3, and then sum them up and generate an output here. And that output will be what's happening here into all these like equations, okay? Afterwards, we're going to apply what we call it an activation function f, okay? What do you mean by an activation function? This activation function can be like we have tons of activation functions. You're gonna hear what we call it ReLU, or rectified linear units. We're gonna see sigmoid. We're gonna see tons of, I don't want you to be intimidated. Let's take a look at a simple, very simple activation function, which is what we call it a step function. So step function has values of zeros if anything is negative. So if for smaller values, if let's say if we have -1, the output of the activation function will be 0. Greater than here, so if you have let's say value of 1, 2, 3, or 4, we're gonna just cap the output to be 1. As you guys can see here, the outcome or the output will be capped at 1. So let's substitute back in our equation. So you guys can see here, if we do the math here, this math will be translated into 2.2. So applying an activation function f 2 to 2.2, because it's obviously greater than 0, then the outcome will be, or the output will be 1. Okay? So that's why the output here becomes 1. Alright, so the question is, okay, what the hell had just happened? Like, what do you mean by this? Like, what's the advantage of having a bunch of inputs, propagate them the weights, sum them up, apply an activation function f, and then generate 1 at the end? What does this mean? This is actually like a very, very powerful concept, which is widely used in AI in general, which is classification, okay? All right, so what do you mean by classification? As you guys can see here, what we have just done, we just sent an input, propagated these inputs to the network, multiply them by weights, and then the outcome becomes 1. Think of 1 as, let's say, the network detected a pedestrian. Like, for example, for self-driving cars, we want to see if let's say, if we take a look at the cameras, we want to see if we detected a pedestrian or not, okay? In the same fashion, as you guys can see here, this is pretty much the same idea. Instead of having the inputs here, we can feed an image. We can feed, let's say, a stop sign, or we can feed an image from, let's say, a camera. And then what the network is responsible for is to just tell me the output would be 0 or 1. Did I see a pedestrian or not? For example, if we wanted to train a network to predict the weather for tomorrow, you can use the same fashion too, the same idea. Like, send an inputs, okay? Teach the network somehow, and it can tell me tomorrow, what's the weather tomorrow? Is it gonna rain or not? Or let's say, should I invest in the stock market or not? Should I retire based on my financial data or not? Should I pass or fail an exam? And so on. And that's the major kind of, amazing intelligence that you can build within our artificial neural network in here using these just bunch of weights. All right? Excuse me. So as you guys can see here, now, congratulations, now we have been able to build a simple artificial neuron. Just one neuron that has a bunch of inputs. You multiply these inputs by values of weights, weight them somehow, sum them up, apply by signal, apply an activation function f, and generate an outcome or output y. You can use it for classification, you can use it for regression, you can, and actually we're going to do that in future episodes, we're going to learn how can we build and teach networks to classify faces, to let's say predict the stock market, look into the future, do wonders of it. Like, think of it as building, kind of a mini brain in a way, which is incredible, really fascinating. So the question is, can we actually use just one single neuron to do something with it? Unfortunately, not so much, because we only have one neuron, right? In our human brain, we have hundreds of billions of neurons. So just, like it's fascinating. Here, we only have one neuron, okay? So what we do in general, obviously we're not gonna build like hundreds of billions of neurons, but what we're gonna do, we're gonna say, let's go ahead and actually build what we call it a multi-layer artificial neural networks, okay? So instead of having one neuron, let's go ahead here and maybe connect, let's say, many of them. So we're gonna say 1, 2, 3, maybe 1, 2, 3, 1, 2, 3, and we're gonna build what we call it a fully connected artificial neural networks. As you guys can see here, we call it fully connected. Why? Because all the inputs coming in here are being connected to the neurons in the next layer here. So all the input going propagated through all the neurons. Input here, propagated through all the neurons, and so on. And that's what we call it a fully connected feed-forward artificial neural networks. Again, this is not the topic for today's episode. Today, we just wanted to build one single neuron, and we've been able to actually build it. And in future episodes, we're gonna learn how can we program this using Python to actually build something with it. You guys can feed, for example, your images, and we're gonna teach that neuron, that network, to do wonders with it. You can use it to classify faces, you can detect smiling faces, happy faces, you can do tons of stuff with it. Okay? Alright, so let's recap what we have done so far. This is our biological neuron, have a bunch of dendrites, sending signals, processing the input in a nucleus, and sending the output to the axon. Let's do that mathematically. So you guys can see here, we have a bunch of inputs, x1, 2, 3, multiplied by weights, summation, bias, generate an output, and then apply an activation function that will generate an output y, which might be 0 or might be 1. Okay? Alright. So, please, again, this is just a quick introduction. In future lectures, we're going to build multi-layer perception networks, and I'm going to see how can we program that using Python. I hope you guys enjoyed this episode, and if you haven't done that already, please subscribe, and we're going to be releasing videos on a weekly basis. I hope you guys enjoyed this lecture, and see you guys in future lectures.